The next section for drainage is the rational method. This method can be traced back to the mid-19th century. Is still the most widely used method for design of the storm sewer because of its simplicity. Once the layout is selected and pipe size determined by this method, rainfall intensity I begin instantaneously and continuous indefinitely. The rate of runoff will increase until the time of concentration when all of the watershed is contribute to the flow at the outlet. The products of runoff intensity and the watershed area A is the inflow rate of the system I times A, and the ratio of this rate to the rate of the peak discharge Q is the runoff coefficient. So it means we can write that the ratio between is equal to C, or we can write this equation Q is equal to CAA, okay, and C is between 0 and 1, okay. And this is we call the rational formula. Q is unit of the cubic foot per second, and I is inch per hour. A is acre, and conversion unit is 1 acre to convert acre inch per hour to cubic foot per second. If Q is a cubic meter per second, we have to use this equation. If Q is a cubic meter per second, I is millimeter per hour, and area is square meter. So this is conversion unit to from square kilometer millimeter per hour to cubic meter per second. The duration used for the determination of the desired rainfall intensity I is a TC. Okay. In urban area, the drainage area usually consists of the sub-area or sub-catchment of different surface characteristics. So the peak runoff is then computed using the summation or composition form of the rational formula. Okay, so we divide the area into J area, and each area is have the runoff coefficient. So we just times the C with the A and summation of CA to get the Q, where M is the number of the sub-catchment, okay, drained by a silver. The assumption associated with the rational method are: the first is the peak rate of runoff at the outlet point is the function of the average rainfall intensity during the time concentration, not resolved from a more intense storm or short duration, or in a portion of the watershed. The second TC is a flow from the most remote part of the drainage area to the inflow point of the sewer. And 3, rainfall intensity is a constant, okay, throughout the storm duration. Next topic is the runoff coefficient. Runoff coefficient is the less precise variable of the rational method, okay, and it's a fixed ratio of the peak runoff to the rainfall rate for the drainage basin, and proper select C is required judgment and experience on the part of the hydrologist. C is depend on the character and the condition of the soil, rainfall intensity, water table, degree of soil compaction, porosity of the subsoil, vegetation, ground surface, and depression storage. So C is depend on many parameters. So C must be chosen to represent the integrated effect of above all factors. Suggest C for various surface types as used in Austin, Texas, given in the table. Here is example of the coefficient from different character of surface, developed area and underdeveloped area. And for example, this one is for different return period from 2 years to 500 years. For example, if the asphaltic surface, the runoff coefficient is 0.73, but the cultivated land is 0.3. So in general, for developed area, the runoff coefficient is higher than the underdeveloped area.